All right, here we go. Polynomials, technically speaking, what we did last unit, this is actually continuing on with that thought process. All right, now, it's not the exact same stuff, don't get me wrong, but you're going to see that that's kind of a build-up to it. Today's lesson, I would say, is primarily review. You're going to see a lot of this stuff and go like, yeah, I've seen this before. What was that again? Oh, yeah, like reminders. You're going to have those kinds of things. And then you can see the first things you're about to go into. Totally that. So a polynomial, you guys worked with polynomials like forever, right? So here's the first thing I want to do. Just looking at it from a graph standpoint. If your leading coefficient is positive and it is an odd, okay, so we have an odd degree. Okay, where am I looking at to find the degrees again? Exponents. So if it has an odd degree and the leading coefficient is positive, then it might look something like this. Right? Like a cubic. You guys have done that forever, like the snake. Now, I don't like saying in behavior. You guys have figured that out. It kind of gets you away from that thought process. We like to say like as the limit as x approaches infinity, right? So the limit as x approaches infinity is what for this one? Infinity. So that means that's the y values it's getting closer and closer to. And the limit as x approaches negative infinity. Negative infinity. As we go really far to the right, the graph's going up. As we go really far to the left, our graph's going down. That's all it's saying, in behavior. All right, now, what if it was negative? How would that change what our graph looks like? Yes. Okay, so it'd be kind of starting up here. And it might, I'm just doing scenarios, by the way. It might look something like that. That would be an example of something that's a negative coefficient, leading coefficient, with an odd degree polynomial. That's just another example. Okay, I made this look a little bit different than that one. Right? You'll see how I had these relative max and min I kind of threw in there, but it's still an odd degree. All right, so on this one, as x goes to infinity, what is our y value going to be? Negative infinity. And then as x approaches negative infinity, infinity. How are we doing so far? Good? Okay, now, what if it's an even? If it's an even right here, what are we going to do now? What's it look like? Parabola. Yeah, that'll work. There's an example of an even degree with a positive leading coefficient. And then as x approaches infinity and negative infinity, they're both going to infinity. As we go to the left forever, it's going up forever. As we go to the right forever, it's going up forever. It's going to go to infinity. Okay, so now a negative leading coefficient, another even degree polynomial, just make it look a little different for us. Might be something like this. This would be an example. Y'all seen graphs like that before? It has a little dip in the middle. There's many of these, by the way. Okay, once again, as we go to infinity and negative infinity, where's it going? Negative infinity for both. Okay, now on these, I didn't do very much. On this left column, but over here on the negatives, I kind of threw some different maxes, relative maxes and mins. All right, right here, the maximum number of turning points is always how many less than the degree? That's right, it is 1. And I'll explain what that means. One thing I need you to add in there, though, is the maximum number of, and that right there should be possible. The maximum number of possible turning points. What do I mean by turning points? What do you think I'm talking about with that?
Like relative maximum.
That's it. So right here, on like this top one right here, this leading coefficient is negative. If we're looking at that one, we can see we had a relative min and a relative max. We had 2 turning points, right? And this, if this was a cubic, would that be possible?
Yeah.
Yeah, because that's 1 less. Could it be a 5th degree?
Yeah.
Sure, as long as it's less, right? At least 1. Do you follow what I'm saying here? Okay, other thing I want to say is this, and you guys are good with it. This one's opening up, right? Like this, sorry. That one is opening up, which means it's concave what? Up. All right, this one over here, get back to this one over here. This one right here, it's concave up, and then round about in this spot, it hits what's called an inflection point. We'll get to that later. Now what is it? Concave down. That's it. That's all concavity is. Yes? So right here, it looks like it's just continuously what? Growing. It's always increasing. So there's not like a turning point. So no, it's 0 turning points. Even though it's a cubic, right? Potentially. So even though it's like potentially a cubic, it's still less than the number, than the degree. What else? What other questions y'all have? Yes, sir.
If there's ever a question that says like, in what interval is it concave up or concave down, do we include the turning point?
Well, okay. I'm going to get to that later. But I'll say this. You don't have to worry about including it. And so by doing this whole parentheses with increasing, decreasing, and later concavity, you never have to worry about it. That'll be it. Let's pass that and we'll get it. Wait on that question. Yes?
When there's an even number of degrees, are like the arrow's always going to point in the same direction?
All right, here's your question. Okay, so let's look at here. If it's an even degree polynomial, will they always be finishing off, like both going up and both going down? Do you agree with that statement? Completely agree, yes. So what would be the counter for the odd? One's going up, one's going in opposite directions. They finish in opposite directions. That's exactly right. What else I got? Okay, so example 1. Here's what I want you to do. I'm staying away. I want to see kind of how you respond to this. It has a set of instructions. Here's what I want you to do, though. All 6 of these, I'm going to give you some time. You and your partner to talk about it. All you're going to indicate is yes, it is a polynomial, or no, it is not. I know it says something about indicating the degree. We're going to do that together. All I want you to do is tell me yes, it's a polynomial, or no, it is not. I want to see what your prior knowledge is on this. Are we good? All right, so give you a little bit and see what you can do. There we go. All right, so on polynomial functions, here's the definition of it. It was a lot of fun to read through and try to figure out. Okay, so it has like all these values that are coefficients or constants. That's what the A's represent. The X's are obviously just your variables. And then N's are the exponents, right? So basically it's saying all that stuff where N is a non-negative integer. Okay, then it has a second statement, which I found to kind of be helpful for some people today. The domain of a polynomial function is the set of all real numbers. You see that sentence? The domain is the set of all real numbers. And I think that's actually helped some people quite a bit. So let's go back down here now, and let's look at letter A. Did you guys think that was a polynomial?
Yeah.
I agree, it is, yes. All right, and we'll come back to it, because we're gonna indicate the degree, but we're gonna come back to that. All right, letter B.
No.
No, it is not a polynomial. So there's a couple of rules of thought. Why would you say it's not?
Domains not negative.
We cannot plug in numbers that are negative in this, right? Okay, another way is this. This is x to the 1/2, right? You can write it like that. The exponents have to be, yeah, whole numbers. All right, so it can't be like a fraction. Okay, over here, answer choice, or letter C. What do you think? This is no. Okay, why?
Domain.
We can't have something in the bottom that creates a denominator 0, correct? All right, and what if I gave you, let me stop right there. What if I gave you something like this? I'm going to take that problem we just had and change it to x squared over x cubed. Your answer would still be no, correct? All right. If you simplified it, I'll say you simplified it, what would that come out to be? 1 over x. Still no, correct? You could also write that as what? X to the -1. What's the issue with that? Besides the domain.
Can't be a negative.
Let's have a negative exponent. You see it? There's a lot of different ways of pinpointing whether something is or is not a polynomial. All right, D.
No.
This one is. Okay, I'll say yes. It's a weird one, though. We'll come back to it. This one's weird. It's horizontal line. Okay, we'll come back to that one. E.
Yeah.
This one's yes. F. Yes. All right, so the degree. What's the degree on this one? 4. Okay, explain to me how we got that. We have, how many terms are part of that, first of all? That word's thrown around. You gotta see that. Terms are always separated by pluses and minuses. So this has 2 terms. So this term right here has the exponent that's the largest, right? So that's a degree of 4. Okay, skip D. E, what's the degree on this one? Be careful with that one. 0. Here's why. There is no x, correct? But if I were to put one in there, what exponent does it have to happen in order to not change the problem? Because what's x to the 0 equal? 1, so that's a 0 degree. Okay, degree of 0 polynomial. All right, here's a little bit trickier one. What's the degree of f? 5. If you took this x minus 1 squared, that would become x squared minus 2x plus 1. Then you distribute the negative 2x cubed, you're going to have a 3 and a 2, which you would add. So the biggest degree is 5. That's the degree of 5. Here's the weird one, letter D. F of x equals 0. All right, well, I'll just say this one has, we'll just say no degree. No degree. That's a weird one. Why do you think that?
Is x to the power of anything times 0 is 0?
Doesn't matter what you raise your x, what power, it's still going to be 0, right? Because you multiply times 0. So that's the only one that's kind of weird. There's no degree. And then you think, well, isn't that just 0? No, there's a difference, actually. It's a weird thing to say. So no degree. Yes, sir.
On E, I'm confused because there's like no x, and a to the first would be
So when you're looking at degree, you only look at the variables. So a in itself is just a number. It's a constant, technically, but when I put the x in there, it's not become a coefficient. But the variable is what you look at. So since the variable has a degree, or exponent rather, of 0, it's a 0 degree.
so you just like add the x.
So, ask me that again.
Like there's no like variables to find it.
Well, if you add it in there, you can. That'd be a degree of 0. He's good. Go ahead.
No, we don't. Sure.
Okay.
Get a question.
Yeah. That clear that up a little bit, Sam? Okay. Any questions about degrees or determining what's a polynomial? That's the basic part. We go any further. All right, so we're going to graph the first one with you. You're going to do this one, the other one with your partner. So x to the 5th. Let's rewrite this. Is x to the negative x to the 5th. I'm sorry, plus 1. What do you think's happening, first of all? Moved up 1. Okay, so we'll do that. I agree. Odd, right? So one's going to finish up high, other's going to finish it down low. Negative, so what are you thinking, Harvey? What's that tell us? Yeah, so up here, it's going to be up over here on the left side of our graph, and it's going to finish down here somewhere, right? Because it has a negative. Okay, now, if we're not sure where it's at, which we're by the end of the class, I hope you'll feel a lot better about this. You can always plug a number in, right? So if you plugged in 1, so it'd be 1 to the 5th, which is 1. Now, negative 1 plus 1 would be 0. So we know there's a point right here. What's the next one you think you should plug in? Negative 1. What happens if you plug in negative 1?
Same thing.
Yeah, you get 2. There's not much going on with this. That's all you got.
Oh, wait, no.
If you want to continue to plug in numbers, you can. But the moment you plug in 2, you're already dealing with 32. 2 to the 5th is 32. But it's just that. You're finishing it off. Yes.
Oh, never mind. Never mind.
I'm not trying to be nothing tricky about these. It's very direct. All right, so you and your partner, you can be, I don't know, just a little bit of time. See if you can get that second graph with the 4th power. All right, so check your answers. Y'all feel good about it? Only thing I want you to really do is just shift it to the right one. That's all it came down to. So understanding you're shifting it. Now the 1/2 and the 3 off, if you plug numbers in, hopefully those numbers are like 2 and 0. So you're dealing with not very difficult values you're trying to multiply. All right, so here's the thing. I'm not as focused on, at this time, always getting exact graphs, depending on the situation. What I want you guys to be able to develop is like how to get quick sketches so that you can analyze something and go to another step with it. That's what I'm working towards today. You're going to see some stuff we're doing. That's why it's happening. All right, so if I gave you something like this, I'll make it. I'll give you something like that. What'd you do? Factor it? Okay. So what would it factor as? X plus 1, x plus 2. All right, so we got that. Okay, now what?
-1, -2.
X equals -1 and -2. All right, now, did I give you any instructions? I just literally wrote x squared plus 3x plus 2 up on the board and said, what would you do? That's all I said. That's the only question I asked. Okay, so this is something that, it's just something we have to get better at math fluency-wise. And it's something that concerns me because I had this question at least once every test. What do I do from here? I'm always giving that, hey, what am I supposed to do with that?
Negative b over 2a becomes.
Oh, okay, hey, exactly. Did I ask you a question on this at all? I just put a trinomial up on the board and said, what would you do? And it turned into us solving for the x's. Do you see the point I'm trying to make? There's no solving involved, period, on this. Why? It's not an equation. Now you might go and try to solve for something. This is an expression. So if you're asking the question like, when am I supposed to solve? Well, first of all, make sure it's an equation. Or I'm saying something like, hey, what are the x-intercepts? Or what are the zeros? Right? That kind of stuff. That's when you do that. You get what I'm saying? Everybody feel good about it? So look at the very top of that next page. All they're saying right here is that's just another way of finding x-intercepts, zeros, roots, solutions. They all mean the same thing. You feel good about that? We're working towards that. The next class will be really heavy on it. It'll be kind of a weird class too, by the way, but that'll be all right. All right, so that's what all this stuff up here is talking about. It's just, hey, here's what it means. You set something equal to 0, and you solve for those particular values of r, then it's called a real zero, or an x-intercept, or a factor. You know, if that's x minus r, that kind of stuff. All right, so skip down to here. Finding a polynomial function from its zeros. So it says a degree of 3, and it gives us our exact zeros here. So if I was trying to find a polynomial function, what would I say?
Y equals x plus 3 times x minus 2 times x minus.
All right, so x plus 3, x minus 2, and x minus 5. Correct? What if I did this? Would that still be a polynomial of degree 3 with those zeros? Yes. Okay. What if I did this? Would that still be a polynomial of degree 3 with those particular zeros? All right. What can I not put in front? Okay, I agree. Another x. Would this would now be a degree of what? 4 with a whole other 0 introduced. So that's out. What else could it not be in
Addition or
front?
subtraction.
So if I put some type of subtraction, if I put minus, that's fine. But if I put another polynomial, yeah, I agree. What else? What number can I not put in front? If I put a 0 in front, what's the issue with that? Everything's 0. You follow it? So the only thing we can't put in front, the only number, only a value we cannot have. Positives are fine, negatives are fine, just not a 0. You good? So for the quick practice aspect of this, I'm going to give you just a little bit of time. Expand all that out for me, please. Multiply it out. Let's make sure we know how to expand it and get everything the right way. So you understand me about expanding. You're multiplying x times x, and then x times 5, and 2 times x. You're getting all that where there's no more parentheses, no more groupings. That good? Let's see if we got it. Okay, so any questions on that? Just expand it all out. Basically, there's no more parentheses. Obviously, you have what kind of degree is that, by the way? Degree of 3. To make sure you understand that it's in fact, who cares if there's a square on this one, the 4, and then a 1 on the 11. All right? All right, so here's kind of the final thing I want to get across to you guys today. And I'll have you answer a couple of questions. Let's see if you understand what you're doing. First thing. Zeros. Put zeros up there for me. Underneath it, we're going to put multiplicity. Okay, well, I'll talk about multiplicity in a little bit. All right, so zeros. What are the zeros for that particular polynomial function? 2. 1/2. Okay, so I'm just going to list them over here to the side. All right, what I want to do is, underneath every single one of those, let's put in that assigned multiplicity. Here's what I mean. If I go to the 2, okay, you guys figured out that 2 is a 0 because which quantity did you look at?
The first one.
This right here, right?
Yeah.
So this x minus 2, that's how you figured out that 2 was a 0. What is the exponent on that quantity? It's a 1, right? That means that this 0 has a multiplicity of 1. Okay, when I'm saying this here, I'm talking about the 2. All right, so now I'm going to go to the -3. All right, so you guys got that from the x plus 3. What's the exponent on that one? 2. So -3 has a multiplicity of 2. Okay, and then one more time, 1/2 is this last quantity, this last parentheses. What's that exponent? So 1/2 has a multiplicity of 4. Which basically just means this. If I took the x minus 1/2, for instance, to the 4th power, that's the same thing as multiplying x minus 1/2 times x minus 1/2 times x minus 1/2. We're doing that 4 times. That's what I call it multiplicity, I believe. Just how many times are you multiplying it? Real simple concept, right? Now, here's what I want you to do. Example 6. Your calculator, have it ready to go. So I'm going to give you a bunch of instructions here. I want you to see what you can do. So relax for a second. I want you to hear everything. Off to the side. About this, just go and do it. Write zeros and multiplicity. List out the zeros for this one. Indicate the multiplicity associated with all those zeros. After that, you're going to go through the instructions. Find the x and y intercept of the graph of f. So go find the x and y intercepts. You can go ahead and plot them over here to the right. Those are not too bad. Those should be pretty good values. Once you have those points plotted, once you've done the zeros and multiplicity, graph it using your calculator. And then use the graph to kind of help guide you to write on the paper. Everybody good so far? At that point, I want you to step back from your partner. I want you to look at this. What does the multiplicity, what do the zeros and multiplicity, what's that relationship? What's happening on the graph with specific values of the multiplicity? I'm trying to be a little bit vague because I want to see if you can discover it. My advice to you is, you have this one graph. Is there a second place to get another graph for us to look at some more data? Well, we just did one here above, right? So we're going to maybe graph this one too, this f of x that we did in the problem earlier. Put that in your calculator and say, okay, what's happening at those zeros when there's certain values of the multiplicities? And see if you can figure out what's going on. Because there is a rule, if you will, for certain multiplicities. Everybody have what we're doing? I want you to try to figure this out. You discover it because it'll mean more to you. It's a lot better than me just flat telling you. And then obviously we'll come back together and make sure we found out the same conclusion. Everybody good? All right, so we get a little bit of time to work on that, talk about it, and then we'll come back together and sum it up. Going again. Okay, so here's our graph that you hopefully got. Now, I didn't graph it exactly right, and that's honestly, that was on purpose. In actuality, the graph hits right here, that x-intercept that you found, hits the y-intercept, and it actually keeps going down, doesn't it? And then it comes, so it's actually coming down here further, and then it goes up. All right, so if you wrote this on a test, and it's like just based on what we've done so far, you would still get it right. If you wrote it out here, and you put like a little dip, and then come back down, you would still get it right. I'm not focused on how far down it goes yet. That's not my concern. Okay, what I want to look at is, obviously you have 3 nice points that you found. X-intercepts and Y-intercept. So what I want you to look at is what's happening when it touches the x-axis. All right, those multiplicities help us figure something out. So for this one right here, this was the x plus 1 squared. The square is an even number. What does it do when it gets to that 1? Sends it back down. It bounces, if you will. It hits the x-axis and bounces back and goes right back down. But over here at the x minus 2, what's the exponent on x minus 2? And if we look at our graph where it's equal to 2, it doesn't bounce. What does it do? It goes through. Now, sometimes it might kind of like flatten out and then go through, but it's still going through the x-axis. All right, so let's look at another one. The one you had before was the x minus 5, all that stuff. Or sorry, x minus 2, x plus 3, and x minus 1/2. Okay, the one from example 5. And we went ahead and graphed it. Does it follow the same rules? Right here at -3, what was the exponent when on the -3? Is it square? Is it 2? It bounces, doesn't it? Right here at 1, what was the exponent? A 4. It's an even number. It bounces. And then right here at 2, it was an odd number, wasn't it? So it's going to go through at that time. Y'all see it? So basically the main idea, somehow I want you to sum that up. Multiplicity, if it's even, it bounces, whatever word you want to say right there. And if it's an odd multiplicity, it's going to go through, the graph is, at that 0. Now you can develop rough sketches of these graphs and answer questions very quickly. What questions do you guys have? Anything I need to clarify there, or we need to clarify? Yes, sir.
So when it bounces, does it have to bounce to the x-axis, or?
Does it have to bounce off the x-axis? Yes, because what's happening is you're looking at like these zeros, and that's where the multiplicities are occurring. It's at those zeros, so that's always going to be some type of event that's occurring at the x-axis. What else you got? All right, so we get like, I don't know, a minute and a half. It won't take very long. Do the last example, please. See if you know what's going on, and then we'll check it. Okay, so on this one, what I want you to do is, okay, first of all, which one is it? What y'all get? B. B is right. Okay, B is right. What I'd like for you to do is, even if you got it, or if you didn't, either way, make little notes off the side, like what's going wrong. Like, so for answer choice A, why is that one not the graph for our polynomial range? The y-intercept on this one's positive, and our y-intercept on this is definitely going to be negative, right? If you plug 0 in for x, all that stuff's wiped out. So A is out. Okay, we said B is the answer, so let's skip to C. What's the problem with C? Too many turning points. Our degree is 4, meaning what's the maximum number of turning points? 3. And this one has 5. Okay, whatever it is. 1, 2, 3, 4, 5 of those. So that one's out. Okay, so letter D. Why is D not the answer? It's opening down. Yeah. This one's opening down. We can see that our leading coefficient, the number in front, is a positive number. Right? So it has to be B. Here's what I need you to add on your paper that's not listed there today. The degree tells us a lot of stuff. Right now, here's what the degree is telling us. This is what you use for this problem. It tells you the possible number of turning points. Right? The possible number of turning points. It also tells you this. If you write this down, it's going to get you. It tells you the possible number of turning points. You have that. Here's what else it does. Let me get this announcement, I'll tell you. All right, so again, the announcement done real quick. So going back, a degree, remember, tells us the possible number of turning points, all right, because it'll be one less. And the other information that a degree tells us, so like this problem right here, a degree of 4, tells us the possible number of zeros that a function will have. So that's how many times that a graph could hit the x-axis. So like this problem right here, the degree is 4, and you can see we had 1, 2, 3, 4 zeros for that problem. So that degree tells you the possible number of zeros you can have. It cannot exceed that. So if it's a degree of 4, we couldn't have 5 zeros. The most we could have is 4. Now you could have 3 zeros if it was x to the 4, or 2 zeros, or 1, or even none. Like just going back like to a very simple one. If you had like x squared, for instance, y equals x squared. Well, that would just be touching the x-axis, right, one time. So that'd be 1 0. But if we were to do something like, add 3 to it, now it's going to shift that graph up, something like this, and now we have no zeros. So even though it's x squared, which means it could possibly have 2 zeros, it will not exceed that number. So it could have 2 zeros, 1 0 if it just touches the x-axis, or none, as in this case drawn right here. So just knowing those two pieces of information with what a 0 tells us is going to help us. And we'll go into more depth in our next lesson to cover that. All right, you guys have a great day.